So in my main function then, I would like to have a cat, right? Cat like this. Actually, let me just name cat a cat and initialize it with a name, right? And so I would like to be able to create a cat like this and be able to create a dog with a different name, like Milo, right? So this is what I would like to be able to do. Then I would like to be able to have a magic container, right? Magic container. It is just an imaginable data type, which is like pets, container of pets, right? And I would like to be able to populate pets container with some kind of pushback, if this is a vector, pushback cat, right? Add cat to that container. I want to be able to add a dog to that same container. And I would like to be able to go back to this container and say pets, say I have pet number 0 in there, and say, I don't know, print, whatever print does. And be able to, this way, regardless what the type of the pet is, I would like to be able to go to individual pets in this container of pets, which of course will have indices. Like when I push back the first pet into this container, its index will be 0 inside this container. When I push back the second pet into this container, the index will be 1. So essentially, if I can write some code that looks like this, this is what we would describe as polymorphic behavior. Why? Because if we were able to add, first of all, a cat and a dog to the same container, that's polymorphic behavior, because all of a sudden we have a container of different types. This is interesting, but also these types behave the same way. Because to both, I can say print and essentially be able to take advantage of the fact that pets can have different types. This code should look to you as magic, because you know that usually if you say an integer, your compiler remembers it's an integer, and if you're trying to do something that integer cannot do, the compiler will resist and complain and be extremely unhappy. So when you say cat and dog and have a container of pets, and all of a sudden you can push in cat and dog into that same container, you should sense that the compiler will not like it very much. So we're going to work on a solution which will actually accomplish this type of code and be able to give us these, these types of functions or functionality. All right, so step number 1. If I want to have a cat and a dog, they have to be created as user-defined types, which in our world means that we're going to say class cat, right? Class cat, and create this class cat just like this, and be able to populate it with whatever information it needs. Likewise, we're also going to define a container named dog, right? So if we do cat and dog, the two types like this, that's the step in the right direction. Right, so this way we can have a pet, which we historically had. That's why I brought it in, and then we have a cat and a dog. Now we realize that both types, cats and dogs, would like to have a name. So if they both would like to have a name, it just makes sense that we can say if cat is type of pet and be able to inherit this name from a pet class. This is probably the right way of doing it. So in other words, instead of saying name here and name here, all we can do is that we can say, instead of essentially explicitly providing a duplicate data field, we can simply say, well, you know what, if we take it from a pet, just like this, it should work. Right? We call this a relationship inheritance. We say that cat inherits from pet. In other words, cat is type of a pet, and this public inheritance allows us to basically reuse all public interface that exists in this relationship. Right, so basically if there's anything public inside the pet, it's going to stay public inside cat and dog, because we say that we want to essentially be able to take advantage of everything that pet already has. So it is, I don't think it's very challenging to create this type of relationship, but let's consider what really happens at runtime when I say cat and dog, right? So now I would like to create a cat and a dog and give them names and be able to manipulate these objects. So what is going to happen here is this. Well, first of all, so we have this class named pet, right? So if I said pet X, right? And actually X would want me to use a name like this, generic name, right? So if I wanted to create it, this is the way it's going to be creating it, right? So there will be an object in memory. Inside there will be a name populated, right? Because this is going to, this name will be populated with something. And if I create a new pet, it's going to be an object in memory. When we say that cat derives itself from a pet, and also dog derives itself from a pet. So if I say create new cat, meow, right? The way the cat is going to look like in memory, that it's going to be another box, which will physically include the pet inside. So anytime a cat is created, actually the pet object is created inside of it, right? Because when we say that cat inherits from a pet, that means that we would like to design pet separate from a cat. However, at runtime, everything is combined together, and guess what? This is the way it's going to look like. Similarly, when I add a dog, right? If I say I also want to have a dog, right? Dog, which also has a name, right? I have to provide some name. Similarly, the dog object is going to be created in memory, and I draw them as boxes, right? But sure enough, inside this container, there will be a pet created, and so both cat and dog will have instances of pet object directly inside their physical memory allocation. That's the way compiler treats inheritance at runtime. It's basically the combination of both concepts which design separately. But look, so therefore, like observation number one about this is that that's why I don't have to give cat a name or dog a name, because name is already here, part of the pet inside cat and part of the pet inside dog, right? So this is going to be another name right here, and these strings are going to be inherited and physically will exist inside the cat and dog objects when I instantiate them, because I said that everything that pet has should be given to both cat and dog, because that's the way I structure these classes. Now, it's interesting that if I try building this, right, so if I just Shift Control S to save everything and say build this project, obviously I'm going to get some errors here. And the first error that is interesting to see is that right here, the compiler is unhappy with this line when I'm trying to create this cat object, that it says that I cannot convert argument 1 from blah, blah, blah to blah, blah, blah. Okay, so it just doesn't, it's actually thinking that I'm trying to use like a copy constructor, and it gets confused because it doesn't know what to do with this argument. This happens because cat has the default constructor, but doesn't have a constructor for a pet, because look, pet cannot be created without a name. Once you specify this constructor that says give pet a name, and then you can create it. Once you do something like this, essentially the pet cannot be constructed, and we have to construct basically to anytime we create a cat, we would like to be able to construct this pet inside, and the same here. We need to be able to construct this. But the cat and dog doesn't know how to construct a pet from within. Therefore, a simple thing to do is that both of cat and dog need constructors. So cat needs to have a constructor that takes a string name. Okay, so that's the constructor here, and likewise the dog also has to have a constructor. Of course, constructors always have the same name, and they better be public, right? We want to declare them as public section in our class, and so this way, if I do just this, then if I want to be able to populate a pet, all I have to do is I can use the initializer list, and I say I am inheriting from pet, and I better call this constructor, because this is the way I can construct a pet that requires a name. And once again, the actual the rest of the constructor is empty. So if I just add these two constructors to cat and dog that use initializer list and say my base class named pet right here requires to be constructed anytime I am constructed, and so I will require the client who is going to be creating a cat to give me the name, and I will pass that name to the pet, and the pet can be constructed successfully with this name, and similar for the dog. So this time things should go better, and now these two things can be constructed. Both cat and dog can be constructed and properly populate the values inside pet with this data field that both classes inherit can be populated. Okay, so that's an interesting observation. Let's save this.